page 330 of your book, section 10.3, cycloalkanes. Now cycloalkanes, they're alkanes, so they're all single bonds, but they're just in a cyclo formation. They're in a ring structure. So when you look at these, they're going to have the general formula of CN. So these will be CNH 2N. That being said, whatever N is, you're going to times it by 2. So you're going to have twice the amount of hydrogens as you are at carbons in the cycloalkanes. So for an example, if you look in your book on page 330, example 10.5, they give you two different options there. The first one, this is just a condensed formula of this. Anytime you see these drawn out like this is actually saying the same thing as drawing out all your carbons like this. It's just a condensed way of writing it. And then off of this one you had your chlorine, and off of all these you're going to end up having, you know, the two hydrogens to fill its octet rule. And this one, two hydrogens as well. So this is the same thing, it's just in a condensed formula, so it's easier to manage and see. So if we're going to name this, we're still going to follow our same rules. So if we go through this, we're going to find the longest parent carbon chain. In these, they're easy to remember because they're in your circles. So wherever we start, let's just count them first. 1, 2, 3, 4, 5, 6. So there's 6. So I know that this is hept. Grab a different marker. This is hept. 6 hex. They're all single bonds, so hex, anes. Okay? So to indicate that it is in a ring formation, all we do is add cyclo to the front of this. Cyclohexane. Now the only thing left to do is we've got to name this halogen here that's connected to this. So this is a chlorine. So we have to count and number our carbons here so that this chlorine has the lowest number. And just a helpful hint, whenever you have these structural rings like this will always be 1. So it will always be at the 1. So there's really no need to put 1 chlorocyclohexane because it's redundant. It's known that if it's in a cyclo formation, whatever you're naming as your substituent first is going to be on the first carbon. It's just a known. So we would write this as chlorocyclohexane. Okay? And again, no need for the 1 because your substituent's always going to be numbered as in a 1. So if we look at our second example there on page 330, now we have a penta ring here. So pent meaning 5, 1, 2, 3, 4, 5 here. So we know it will be A and E ending because they're all single bonds. 5 is pentane as the ending. I have to indicate it's a cyclo, so CYCLO, cyclopentane. Now I have to name the substituent. Again, there's no need to name the 1 because it's redundant. It's in a cyclo formation. We know our substituent will be at 1. That being said, if I had 2 off of this, 2 different ones, I would have to put it for the second one. We'll get to that in a sec. But for this one, this is our methyl group. So it would just be methyl cyclopentane.